All right, yesterday we did special right triangles, but we did a certain type of special right triangle. What was that yesterday?
45.
Yeah, so yesterday we did 45, 45, 90. And we had a special thing that we had to remember for it. Do you remember what that was? The hypotenuse? It's not 2. It's the square root of 2. It's a big difference. Remember, 2, or the square root of 2 is like 1.414 or something like that, okay? A 2 is a 2. 1.4 and 2 are completely different numbers. Agreed?
Yeah.
All right, so it's the square root of 2 times one of the legs. So what we're going to do today is we're going to learn about a triangle called a 30, 60, 90 triangle. So I'm not going to draw this like exact or anything. I think on this program I might be able to get it to figure out an exact 30-degree angle, but I'm not going to bother. I'm just going to make it kind of look like it. There is. Yep, because of that right there. So 90-degree angle. So again, we're dealing with right triangles again. And look at the title. Special what? Right triangles. So you know you got to have a right angle in here. Okay, so we have a right angle. So guess what the other two angles are going to be? Take a wild guess. 30 and 60. Very good. See, you guys are right on it. Okay, so there's your 30, 60, 90 triangle. Now, instead of one thing, like on that 45, 45, I'm going to put it in a box because when I put it in a box, it means it's important. Okay, so that's something that you need to know. On a 30, 60, 90 triangle, if you remember yesterday, I kind of alluded to this. There are two things that you had to remember instead of just one. Actually, if you think about it, on that 45, 45, 90, there were two things you had to know. What'd you know about the two legs? That they were the same. But that was so easy, it's hardly even worth writing it down. Would you agree? All right, but it's important. But now what we're going to do is we're going to do two things with a 30, 60, 90 triangle. But before we write those two things down, let's label the three sides. Remember, on a 45, 45, we had two legs that were the same, and we had the hypotenuse, okay? So we still have one of those things here. What do we have? We got a hypotenuse, okay? So this is our hypotenuse right there. How do I know it's the hypotenuse? Because it's what? So it's opposite the right angle. It's across from the right angle, okay? So we know that's the hypotenuse. Now, these two are legs as well, but if you look at them, they're not equal to each other, okay? They are not the same length, okay? So this one looks what in comparison to this one down here? Looks smaller, looks shorter, okay? That's the word we're going to use, actually, okay? We're going to use the short leg. So we're going to say the short leg. And this right here is the long leg. Okay? Now, if you look, I don't know if you remember, but from geometry, if you have a triangle right here, the side that's opposite the smallest angle will always be the smallest side. Everybody hear that? The side that's opposite the smallest angle will be the smallest side. All right? So guess what's true about the hypotenuse? The hypotenuse is opposite the 90-degree angle, which is the largest angle. So the hypotenuse has to be what? The largest side. Exactly right. Okay? And what about the 60? The 60 is like the middle one, right? So this is the shorter one right here. This is the middle one. This is the longest side. But I don't use the word long for this because the hypotenuse is always going to be the hypotenuse, all right? And it's always going to be the longest side of a right triangle. Always, every single time. It's always going to be the longest side of a right triangle. Everybody got it? Okay. So this we just call the long leg, or some teachers call it the longer leg, right? Comparing it to the short leg. Short leg, long leg. Everybody got it?
Yeah. Are you going to find the number of legs because one's twice the size of them?
Exactly right. And you remember it from, how'd you remember that? From geometry class? Oh, you just looked? Okay. And she's absolutely right. There is one that's twice as big as the other one, and that's what we're going to do right now. Well, first of all, we got to compare, we have to label short leg, long leg, because that's the words we're going to use, okay? We're going to use short, and we're going to use long, okay? So that's what it means. So the first one, let's do the easiest one first. So we'll say the hypotenuse is equal. Now in a 45, it was equal to the square root of 2 times one of the legs. But this one is 2 times the short leg. I can't just say leg because they're two different sizes, right? One's short, one's long. I can't just say leg. On this one, I can just say leg because both the legs were exactly the same. On this one, I got to differentiate between the short one and the long one. You got it? All right, so it's twice as long. So let's just do something super easy. What if the short leg was 5? Tell me what the hypotenuse is going to be. It's going to be 10. That's exactly right. This will be 10. Why? Because the hypotenuse is exactly double, it's twice what the short leg is. So if I know the short leg, I just multiply it by 2. Right there's a little formula, and I got the hypotenuse. Everybody see that? What if, let's get rid of that. What if, let's just use a different number. Let's use 8. What if the hypotenuse was 8? What could you tell me about the short leg?
4.
It's less than 8, that's true, but you should be able to tell me exactly what it is.
4.
You say that with a question. Are you sure? Or are you just guessing?
It's 4. Final answer.
Yes. Final answer, you are correct. It is 4. Why? Because the short leg is half of the hypotenuse. If the hypotenuse is twice the short leg, then the short leg has to be half of the hypotenuse. Agreed? All right. So if this is 8, then this has to be what? 4. Got it? Okay. Yeah, that's not too bad. But now, the long leg. The long leg is kind of like what we did with the 45-45. Okay? So what we're going to do is we're going to compare the long leg to the short leg. And if you look at both of these, after I write this down, both of these are being compared to the short leg. The short leg is the one that's super important. So I'm going to take that hypotenuse, compare it to the short leg, and then I'm going to take the long leg and compare it to the short leg. Okay? That helps a little bit on remembering these formulas right here. So the long leg is actually the square root of 3. Now you're wondering, where in the world do they come up with the square root of 3? Well, we could sit here and show you where the square root of 3 comes from, but we're not going to today because we just have too much to talk about and not enough time, especially for the end of the year. All right? But if this was and I did this in my honors geometry class, we did this like last chapter, and we discussed where that square root of 3 came from. They saw it. They weren't very impressed, but they should have been. They should have been impressed because it's kind of cool to see where the square root of 3 comes from. It's not, they didn't just pluck it out of the blue. All right? It actually works out kind of nice. But it's the square root of 3 times the short leg. Remember, both of these compare to the short leg. Everybody see that? The hypotenuse compares to the short leg and the long leg compares to the short leg. So the short leg is the one that's super important on a 30, 60, 90 triangle. Everybody good? Okay. So now you kind of understand it. But now we got to do some examples. Would you agree? Yeah, let's do some examples. So let's should have. Do I have that right triangle over here? Nah, I'll just make one up myself. So again, it's 30, 60, 90. Whoops. Let's make it straight up and down like this. And then let's make one go like this. And let's make one go like this. All right, good enough. There's a right triangle. And let's do this. Let's just copy this so that I can use it again. I don't have to redraw it every time. All right, here we go. It's 30, 60, 90. So there's 30. What does this have to be right here? This has to be 60 because remember, the two acute angles of this triangle, they add up to 90 degrees. They all add up to what? 180, right? So there's 90. These two are 90. It's 180. So if that's 30, that has to be 60. All right, good enough. Let's actually do one right from your homework. You okay with that? I'm sure you would be. Let's do this one. All right, they make that 2, and you got to find the other two sides. We'll call this B. We'll call this C. So this is a problem right on your homework. This is what's going to be on the quiz. This is what's going to be on the test. Okay, something very similar to this. Now the first part, I mean, this is almost identical to what we just finished doing. All right, so it's not really any different. But the first part right here should be pretty easy. We just talked about it. So remember what the what your little formula thing is? Remember the hypotenuse is equal to what? It's twice the short side. Okay, so that's what we're going to use because they tell us the short side. How do I know that's the short side? Just because it looks like it according to the picture? It's across from the smallest angle. Exactly right. Okay, it's opposite the smallest angle. You guys are watching. That's good. All right. So this is the short side. Well, it's just equal to 2, like 2 centimeters, 2 inches, 2 whatever. Okay, so that's the short side. But we have a relationship here. This is where we're going to do the twice thing. So the hypotenuse, which is what in this situation right here? What's the hypotenuse? It's C. So C is equal to 2 times the short side. Well, what's the short side? It's 2, right? It just happens to be 2. Has no relationship between this 2, right? They just made it 2, right? And so what is the hypotenuse then? It's 4, okay? It's just 2 times 2. Pretty easy, right? So if you know the short side, you just double it, and you find the hypotenuse. Piece of cake. You with me so far?
Yeah.
Okay. Yeah, that's easy. Here's the part that may be a little bit trickier, but actually, to tell you the truth, on this one, it's actually a little easier because we actually had to do some multiplication here. We actually had to know what 2 times 2 was, all right? Which isn't hard, obviously, but you actually had to do some math. On this one, the long side, B is the long side. Well, let's write it down before we write that. So let's write that down. Remember what it is? Should be on your paper. The long side is what? Square root of 3 times the short side. Remember, they both compare to the short side, right? Okay, so it's 2 and square root of 3. Here's one way I can kind of remember square root of 3. The long side is just a little bit smaller than the hypotenuse. Well, a little bit could mean different things for different people, right? But here's what I mean a little bit smaller. Why is the square root of 3 just a little bit smaller than 2? Well, I'll show you. Because 2 is the square root of 4, isn't it? Okay, so the square root of 3 is just a little bit what? Less than or smaller than the square root of 4. Do you agree? That's how I remember it. I remember that the long side is just a little bit smaller than the hypotenuse. Well, the hypotenuse is twice the short side, right? Which is the square root of 4. The long side is just a little bit smaller than the square root of 4. What's a little bit smaller than the square root of 4? Square root of 3. Exactly. Does that help a little bit? I don't know. That helped me, right, when I was learning this stuff. All right, so that's how I can remember the square root of 3. All right, let's put some stuff in here. Do I know the long side? No. What is it? It's B, right. We labeled it as B, so I'll call it B. Equals the square root of 3 times the short side. So the square root of 3 times the short side. What's the short side? It's 2, so it's times 2. But I don't write it like this. How do I write it when I have a whole number and a square root next to each other? I always write the whole number first, right? So I would write it 2 square root of 3. That technically would not be wrong. I would give it to you. But this is the better way to write it. We should just write it the way that you're going to be seeing it, okay? If I read off an answer, or if you see the answer in the back of a book or something like that, they're going to write it 2 square root of 3. They'll never write it square root of 3 times 2. Now, do I multiply that 2 and that 3 and get a square root of 6? No. When's the only time that I would get a square root of 6 out of it? If it was the square root of 2, right? If they were both square roots, if this was a square root of 2, then I can multiply them together. But it's a whole number, so I can't really multiply those two numbers together. I just stick them next to each other, and that shows that they're multiplied together. Make sense? Yeah, that's not old stuff. That's new. That's not new stuff. It's old stuff. All right, so B is what? 2 times the square root. I'm sorry. Yeah, 3. All right, and what did we say C was? It was 4. So there you go. You've got the hypotenuse, and you've got the longer side. And really, it wasn't even that difficult. Did I need a calculator for any of that? No, didn't really need a calculator for that at all. Now, there might be times you could use a calculator, but these are special triangles. They're special because we don't really have to. Anyway, forget it. I don't know what I was going to say. Yes, sir. 7? Yeah. Yep, let's do that one. I did 8 first, so this was number 8 on the homework. I did that one because that was the easiest one. Okay, number 7 is actually a little tougher than this one, so let's do number 7. All right, it's the same idea though. It's the same idea, except you're going to have to divide, and you'll have to divide by a square root, right? Which shouldn't be a big deal because we talked a lot about that yesterday. So let me draw this. They write the triangle a little bit different, but it's still a right triangle. And let's see, it looks about like that. And this looks, that's pretty close. May not be exactly, but that's okay. All right, so there's your right angle. They tell you that this one is X, this one is Y, and this one they tell you the hypotenuse. Okay? Actually, this one's not that hard. There's another one. There's one when they just give you the long side. That's where it gets a little bit tricky. Okay? Nana, find me one where they just give you the long side on a 30, 60, 90. Okay? We'll do it. You find it and tell me when I'm done with this one. Okay? So we got two things. I'm going to write it down again. Right? Again, when you're trying to remember these things, it might be a good idea to write these down every single time. You could always write it at the top of your paper, then look at it, but you're only writing it once. If you write it down a whole bunch of times, you're going to remember it a little bit better. All right, so the hypotenuse is equal to twice the short side, correct? Yes. Go ahead. All right, yeah, find the short leg. What's that going to be? Yeah. Right. Yep, so this is the hypotenuse. And which one is the short leg, the X or the Y? The Y is, okay? Now, I should have put a number in here because I can't just go by what it looks like, but I should have done that. Okay, so if that's 60, what's this one? That's 30. That's how you know the Y is the short leg, okay? I mean, I guess you could just go by looking at the triangle and saying, yeah, that's shorter than this one, but you're exactly right. You hit it right on the nose. So this is going to be, what'd you say it was? It's going to be 8 because it's half of the hypotenuse, right? Hypotenuse is double the short side, right? Or the short side is half of the hypotenuse. We got it? Okay. Now, once we know the short side, it's clear sailing from there, isn't it? Once I know the short side. So now I can find the long side. Let's write down one more time what the long side is. It's the square root of 3 times the short side. So now I know the short side. I had to find that first though, didn't I? Actually, I didn't have to, but it's a lot easier if you do it that way. So I got the short side. So the long side, which is X, is equal to the square root of 3 times the short side, which is 8. But I don't write it like this. How do I write it? 8 square root of 3. Okay? All right. So X is equal to that. So that's what X is. And we already found out what Y is right there. Piece of cake. Not that hard, is it? No. All right, Nana, give me one. 16? Let me see, 16. Yeah, they give you the long side. That's a good one to do. They actually made it kind of easy for you, to tell you the truth. Number 16. We'll do that one first, and then I'll make one up myself. Okay, that's maybe a little bit tougher. But let's take a look at number 16. Man, I'm doing like half of the homework for you, so hopefully you're writing these down. This one goes like this, and it goes like this, and like this. All right. All right, 16. So this is A, this is B, and they tell you this is 11 square root of 3, and they tell you this is 30 degrees. Again, you can't make an assumption. You cannot make an assumption that this is the 30, 60, 90 triangle. But now we know exactly it's 30, 60, 90, don't we? Okay, because if that's 30, this has to be what? 60, and there's your 90. Okay, good to go. Little bit of a problem with this. I don't know B. I don't know the short side. And I don't know the hypotenuse. So I can't just take half of it to solve this. All right? So let's write it down, though, okay? So the hypotenuse is equal to what? Twice hypotenuse. It's twice the short side. And the long side is equal to the square root of 3 times the short side. Now, we're not going to cube anything because we're not doing the cube root. It's a square root, okay? But we're not going to square anything anyway. So watch what we're going to do. Let's use, what do you want to solve for first? I would solve for the short side first, okay? Just because if you know the short side, then you can find the other stuff. By the way, you couldn't solve for the hypotenuse anyway, could you? Right off the bat. Because you don't have anything with long side and hypotenuse. Do I have anything with long side and hypotenuse? No. I got long side and short side. I got hypotenuse and short side. So I have to find the short side first. Agreed? So what do they tell us? They tell us 11 square root of 3, which is the long side. How do I know it's the long side? Or the long leg? I should say long leg, all right? Because it's opposite the 60. Okay, it's opposite the 60. So that's the long. Okay, so it's 11 square root of 3 equals, let's write in our little formula. Square root of 3 times the short side. What's the short side? B. And now I just have to do a little bit of math. It's really not hard math. Remember when I said they made this kind of easy for you by putting a square root of 3 here? Okay, they did. And I'll show you why now. So I get b by itself, so I divide by the square root of 3, divide by the square root of 3. That cancels, so I have b equals what? 11. So b equals 11. Now once I find the short side, the hypotenuse is easy now. What do I do if I know the short side? I multiply it by 2. And do you even have to show that? I don't think so. So you can put 22. And there you go. We good? All right. Let me show you the one that's probably the worst out of all of them. Okay. So let's do the same basic problem. And I'm going to give you the long side again, but I'm going to give it to you as a whole number. And at first glance, it looks like, oh, that would be a little bit easier. But what are we going to do? Remember, dividing by a square root of 3, right? So if I take a whole number divided by the square root of 3, can I keep it like that? No. So I have to, can't keep the square root on the bottom. Remember that? I'm getting ahead of ourselves. So let's make this long side. I don't know. Let's give us a number. 2's too easy. What? 5? All right. Let's use 5, and that's the only thing that we know. All right. So we'll make that one the 30 and make this one the 60. Okay. And we'll call this B and C. Okay. Now look what we have. We have the hypotenuse. We basically have the same exact situation that we had in the last problem that we just did. You're correct. Very good. I said hypotenuse, and I was corrected by Breon. Breon Sims for everybody. He's the smart one. He's the one that corrected me. All right, so the long leg. I'm given the long leg, and I got to find the other two sides. Carter. Okay. Like off the top of your head? Okay, what is it?
Is it 5 square root of 3?
Not quite. Can anybody do it in your head?
It's going to be square root of 3 over 5.
Is it? Look what we did on the other one. Here, let's try to do a little bit of this in our head. We don't have to do the whole thing in our head, but a little bit of it in our head. When we're given the long side, how did we find the short side? What do we do to that longer side, that longer leg? We divided by what? The square root of 3. You see that? So if I know the long leg, how do I find the short side? I divide it by the square root of 3. Let's come over here. I know the long leg. How do I find the short leg? Divided by the square root of 3. So what's that going to give us? 5 over square root of 3. That's right. So now we don't like it like this. Why don't we like it like this? Because the square root's on the bottom, right? And math teachers for a long time have said we don't like the square root on the bottom, okay? So what we're going to do, did this yesterday, we didn't do it with the square root of 3, we did it with the square root of 2, but it's the same thing. Yep, multiply by the square root of 3 over the square root of 3. Now, did we just pick that out of the blue? Because this is a 1. And we can multiply anything by 1, and we don't change the value of it, correct? All right? But why did we pick the square root of 3? Why didn't I pick the square root of 5? Because square root of 5 over square root of 5 is a 1. Why didn't we just do that? Because this gets rid of the square root. That's right. If I multiply it by itself, and what do we do when we multiply things by itself? We're really doing what to it? Anything, no. If you multiply something by itself, you're squaring it, aren't you? Okay? So if I square square root, what happens? They cancel out. So what am I left with? Just a 3. Everybody see that? It's a nice little trick. It's not hard to understand, is it? All right, we multiply it by itself to get rid of the square root, and I do it to the top and the bottom. And a lot of people say, oh, whatever you do to the top, you do to the bottom. No, that's not the rule. What's the rule with that? Whatever you do on the left or right on one side, you do to the other side. Okay, that's that rule. That's a different rule than this, right? This rule is because we're multiplying by a 1. All right, my word, everybody scam calling me today. All right, so I've got what? 5 square root of 3. So that is the hypotenuse. I'm sorry, that's the short side. Thank you. That's the short side. 5 square root of 3 over 3. Everybody got that? Okay, so if I know the long side, how do I find the short side? I divide by the square root of 3. All right? Now, how do I find the hypotenuse if I know the short side? Multiply by 2. Can you do that in your head? If not, we'll write it down. Multiply that by 2. Remember, we're doubling it. So what are you actually multiplying? Am I multiplying the square root of 3 times the 2? Not really. The 5 and the 2. Okay, so what's 5 times 2? It's 10. And then what do I write? Square root of 3 over, don't forget the bottom, 3. Does anything cancel out? No, 3 doesn't go into 10. And so that is my hypotenuse. It's 10 square root of 3 over 3. Okay? Everybody got that? So look, the hypotenuse is double the short side, isn't it? Because if this is the short side, what's this double? Well, I just take 5 and double it. It's 10. 10 square root of 3 over 3. All right? Everybody good?
Yeah.
It really, these 30, 60, 90 triangles don't get any harder than that right there. I don't think. Maybe if you put a square root of, I don't know. Let's just test something. See if it's any harder or not. I don't know if they do this on the homework or not. Yes.
So, like, the number beside the square root, that wouldn't change.
That's correct.
Why wouldn't it change?
Because when I take a whole number and I multiply it by a square root, I can't multiply those together. All right? There's no rule that allows me to do that. Now, if I had this, though, now watch carefully. Now, this doesn't have anything to do with this problem, but watch. If I had the square root of 5 times the square root of 3, then you can multiply them together. Okay, because they're 2 square roots. When I multiply 2 square roots together, I make one big square root and just multiply those 2 numbers together. So 5 times 3 is 15. So in fact, let's just do that. Let's make this, let's just start from scratch. Yep, there's my triangle right there. Let's make this, I don't know, let's make it a weird number. Let's make it like the square root of 7, okay? And let's say this is 30 degrees. Everybody with me? And we're going to solve for B and C. Let's scooch this over. Everybody good so far?
Yes.
All right, so we made it real weird looking. We made it a square root of 7. All right, so let's see what we're going to do with this. That's the long side. So what's the first one I'm going to find? Long side is equal to what? Square root of 3 times the short side. Or leg. I keep saying side. I should be saying leg. All right, but you know what I mean. Okay? So what do we know? Yeah, but what do we... Here's our formula. What do we know in this triangle that we can throw into our formula? The long side, right, the long leg, okay, the square root of 7. So I can put the square root of 7 right there. Everybody with me? And you're right, you could just in your head think, oh, let's just divide by the square root of 3. But I'm going to show you why you're dividing by the square root of 3. Times the short leg, which is B. All right, so what are we going to do here? I doubt they give you one like this. It doesn't look like they do. Yeah, so, but I know, I'm just trying to make this problem a lot harder than what you're going to see. But let's see if we can do it. So we divide by the square root of 3. We divide by the square root of 3. Everybody with me? So what's B equal to? It's the square root of 7 over the square root of 3. Right. You don't like the square root of 3 on the bottom. So what are we going to do? Multiply top and bottom by square root of 3. The bottom is 3. Now, this is what we just talked about. What's the square root of 7 times the square root of 3? That's it. Square root of 21. Now you're getting the hang of it, right? It's not that hard to multiply square roots together, right? All right, as long as you know to put it under one big square root, multiply those two numbers together, and that's the square root of 21. That's what b is equal to. That's how we would write b. It's really the best way to write it. It's the best way to write the exact answer. If I was an architect or if I was a carpenter and I'm trying to figure out what the length of that side should be, all right, I wouldn't say, oh, the length of the side is the square root of 21 over 3. Now, what would I do with that if I was a carpenter? I'd put it into a calculator, make it a decimal, absolutely, okay, to figure out what the actual measurement is, okay? But we're not carpenters right now. We're just high school math kids, all right? So we just leave it like this, all right? That's the exact answer. That's what we're looking for right now, our exact answers, not approximations. When you cut stuff, when you make stuff, when you build stuff, you will be using approximations, okay? But we're not doing that right now. We're just doing exact answers. You with me? Now, C is the hypotenuse. Since we know the short side now, what do we do to find the hypotenuse? We multiply by 2. So how in the world do I multiply the square root of 21 over 3? How do I multiply that by 2? Yeah, it's a whole number and a square root. You can't combine them, so you just write 2 square root of 21 over 3. And that's how you would write it, just like that. Is that what you were saying? Yep. So it's 2 times the square root of 21 over 3. That's how you would do it. I don't see any on the worksheet that are like that, so you don't have to worry about that. But anyway, that's how you would do it if they gave you that number. We good? Yeah, it's not so bad. Did you guys do this in geometry? Do you remember? I think I had like 2 people raise their hand. A couple, 3. You got a couple nods. But at least you remember the teacher talking about it. I'm not saying you remember how to do it, but okay. Well, that's good to know. All right. We only got a few minutes left. Let me I'm going to stop YouTube, and then I'm going to read off the answers to the 45, 90s, and then we'll take questions tomorrow, okay? Take questions tomorrow, and then Friday we'll take a quiz. We good? All right.